Hi there, David. I decided just to do a video here to show you how you can use a automotive 12 volt relay, and this is your standard 12 volt automotive relay. And if you look at the leads here, these two on each side here are actually the coil to activate the relay, and this lead here is a switching whatever you want to do with this lead. You can put let's say your negative lead here, and between these two contacts, when the relay coil isn't activated, this is a closed switch, and when the relay is activated, when the relay coil is activated, then this becomes unswitched, and it switches from here to here now. So I'll just show you a really simple thing here to do with the relay. So let's just test the relay here. We'll put our positive here and our negative here, and as you can hear, the relay is being activated. So all what we need to do here is to just put our negative here, and now if we have a small jumper from that center lead to the side here, the relay will start oscillating, and that's a really high frequency, but unfortunately it's not holding on long enough to be able to flip the relay to come and make contact at this side of the switch. So I'll just stop it now. Okay, so that's the basic circuit. So that's all you need to do there. Get the relay to hum like that, then you know you've got it done right. So for the relay to hold on to this other side here, which is the side where you can be utilizing your negative, you can use one battery to operate the relay, and maybe the other one for operating your PWM circuit, and then put your negative from here, same where this negative is coming, right here, and this going to your PWM. Now, in order for the relay to hold, on that pulse here, okay, all what we need to do is just add a little bit of capacitance. And here's a 680 microfarad capacitor. It doesn't have to be 200 volts, as long as it's rated up to 12 volts. Maybe work something 25 volts should be very safe. And what we do is just here on each side, okay, this is the negative side of the relay, and my white lead here is the positive side of the capacitor. So if I put that on the positive right there, so right there, just adding that capacitance, and now if we put the power back on, now the relay is oscillating, you know, and really making contact all the way to this side, because it's holding on, because it's got that extra capacitance here, stored energy, and then it flips back, gets recharged, and flips back again. So the higher the capacitance you put on, the longer the period of flipping up here will be. And the other thing you can do, if you want to adjust duty cycle, you can use a little magnet here. For instance, see here, you'll hear the sound. Alright, so by positioning the magnet at different locations, you'll get different duty cycles. Okay, that's just forcing the, well, I guess it's the magnet is actually helping the coil to trigger and hold on, in different periods of time. So you can finally adjust the duty cycle. Now, if you want to look at what happens if we place a bulb here, let me get a bulb. If we put our bulb here on the positive side here, try to get a connection there. Now you can get a visual display here. So now as you see, that bulb is flashing. So it's mostly on, and just creating a small off So just creating a very small, short off period. And I think that's what you're looking for. And if I move the magnet around, see if I remove it, it becomes much faster. The off period is very, very small at that time. And by moving the magnet, I can create a longer off period. So I think that combination there might be good for you to try and to play around and test your the effect that you're finding there. All right, I hope this helped you out. And you know, here again, if I remove the capacitor, so obviously the switch is not making it there because there's not enough energy. And if I put a lower value capacitor, this one here is a 330 microfarad. So if I connect that up, all right, so now we have a higher frequency. So it's that simple. All right, so hope this helps you.